Here we go. We have a question fixing two nodes of a BST. So you have given the root of BST where exactly two nodes were swapped, and your task is to fix the BST. That's it. We have given this example, and in these nodes 20 should be here and 8 should be here. So then it will be BST, but 20 and 8 is swapped, so we just need to again swap the corresponding nodes to correct the BST. And in this example, can you guess which node we should swap? The answer is 10 and 5. So if we swap 10 and 5, this is the correct BST. That's about the question. It's a hard level question, we can say. Now let's build the approach. So I have taken this example, and in this I have swapped 5 and 2. So we need to just correct it. If I correct it, 5 will be here and 2 will be here, so it will be 2 and 5. Now this is the correct BST, but this is the input, we need to correct it. So first of all, let's find the pre-order, because we know pre-order of BST is in sorted order. So first we got 5, 2, 8, 10 and 20. I hope you already know what is pre-order and how to find it. And in this I have swapped 8 and 20. So 20 will be here and 8 will be here. Let's find the pre-order for this. The answer is 2, 5, 20, 10 and 8. And in this I swapped 21 and 10. Yes, this is the correct. So this here it will be 22 and here it will be 10. The node no I think let's make a pause. So I have this example. So this is the correct BST. I hope this is the correct BST. Yes, this is correct. So if I swap this and this, the value 23 will be here and 21 will be here. So the pre-order of this tree is this, right, then left, and in this example 10 will be here and 5 will be here in the correct BST, but I have swapped this and this, so the pre-order will look like this: 2, 10, 8, 5 and 20. So can we observe a relation? The relation is, if I swap this value with this value, we got the answer in sorted order. And in this case, in this example, 2, 5, then this 20 is correct, then the value should be greater in this place. So the value that we need to swap is this and this. And in this example, this is increasing, then this is decreasing. So this, then decreasing, then increasing, it is correct, increasing. So till here it is increasing, then decreasing, then it is increasing and increasing. So it will be 24. 24, is it 24? So actually in this example there are two cases. If I swap 24 and 21, it will not create. Yes, there's only one solution for this, and the solution is increasing. This is the topmost, then we have a decline. So this is the next node that we need to swap. So this is the observation, and increasing then decreasing. So this is the topmost, this is the decline, this is the next decline. So we need to swap this and this. So I hope you got my point. So what do we mean? Increasing, then we got decreasing. So this is the topmost and this is the downward. So we need to swap 5 and 2. Same for this, increasing, then decreasing. This is the bottommost and this is the topmost. So we need to swap this and this node. In this same observation, increasing, then decreasing. So this is the bottommost, this is the topmost. So we need to swap this and this. Same for this, increasing, then decreasing. This is decreasing. This is the bottommost decreasing. This is the topmost increasing. So what we need to do? First, any value that is increasing, any value that is increasing, this will be our first node. This can be our first node. Then this node is also greater than previous. This also can be our first node. Then we have decreasing. The value is smaller than previous value. So this will be our second node. This value is also smaller than the previous value. So this will be our second node. This value is again increasing. So after that, any value can be, every value will be in increasing order. So there's only one hill and mountain and hill, you can say. This is the topmost part, this is the bottommost part. So we just need to swap this and this node. So let's check for this. This can be our first node because before that we have infinity. This is greater than previous value. This will be our first node. This is also greater than previous value. This will be our first node. This is also greater than the previous value. This will be our first node. This is smaller than the previous value. So this is our second node. Our first is already filled. This is our second node. Then again we have a node, but this is increasing. If we found our second node, we will not change the first node. We have already found our first node before that. First node is in increasing order before the second node. First node is in increasing order before the second node. So this is the second node, and after the second node we are increasing, but we are not. So this node we don't care. After the second nodes we don't care at all. We just need to swap first and second node. So this is obviously greater than previous, but our second is already initialized, so we will not change our first. This is again greater than previous, but our second is already initialized, so we will not change our first. This is obviously greater than previous, but we already assigned our second node, so we will not change our first. Then this will be our first node. This can be our first node because this is greater than previous. This is greater than previous. This will be our first node. So we are reassigning our first nodes. This is again greater than previous. This will be our first node. Then this is smaller than. So this will be our second node. Again, this is smaller than the previous node. So this will be our second node. That's it. We have found our first and second. So this will be our first node. Then this is decreasing. So I will assign my second here. Then we have increasing. This is increasing, but our second is already assigned. If our second is null, then only we will reassign our first. If our second is already assigned, we will not change our first. So after finding the first and second node, we know what will be our first node, we know what will be our second node. Then we again do the iteration in this. Is it equal to first? No. Is it equal to first? No. Is it equal to second? Yes, it is equal to second. So we will change it to first. In the second iteration, we know what will be our first and second node. And if the node data is equal to first, we will swap it to second. If the data is equal to second, we will swap it to first. This data is equal to first, so we will change it to second. We will change it to second. And using this, we have our correct BST. So let's do the same for this. We know our first is 20, second is 8. Is it equal to 20 or 8? No. Is it equal to 20? Is it equal to 8? No. Is it equal to 20 or 8? No. Is it equal to 20? Yes. So change it to 8. Is it equal to 20? No. 8? No. Is it equal to 8? Yes. Change it to 20. Then in this we have 23 and 21. Is it equal to 21? Yo, yes. So change it to 23. Is it equal to 23? Change it to 21. This is the correct. Is it equal to 5? Yes. Change it to 10. Is it equal to 5? Change it. Is it equal to 10? Change it to 5. Yes. So that's how it will work. Let's code this. We have global A and B. We have null. Before that, let's do the simple pre-order. So we have previous. So previous will be very small value. This is the pre-order of root, pre-order of node. If node is equal to null, return pre-order node dot left, then current node, then node dot right. So for the current node should be greater than previous node dot data. This must be true. So if this is not true, we want to store it. So for this value is correct. We have inclining. So this will be our first node. This will be our first node. We just need to store the data. So we have two things, A and B. A is null, B is null. So this will be our first node. If this is declining, just store it. So we will store it. This is declining, this is not true. And again, after the declining, we have inclining. So we need to store the node data if and only if our B is not assigned. So if your B is null, then only store. So you can also check your A and B here. A and B, but I am sure we will get the correct data. So after that we just need to correct it. So I have correct function root. So this is very simple. Correct function is very simple. Correct. So let's name it correct BST. You can do in order, pre-order, post order, anything will work here. If this is base condition, just return correct BST, left or right. If node data is equal to A, so change it to B. If node data is equal to B, node data will be A. This is else if either this or this. So I hope it will work. Let's submit it. And yeah, we have a mistake. Modified BST node already. Acha, correct BST is already defined in the class solution. Correct BST is already there, I think. Method correct BST is already defined in class solution. Is it here? Compare. No, I don't think so. Correct. BST. So we have previous is not defined. So first of all, correct this. So I have corrected, and we are not changing the previous. So first of all, change the previous. This will be my current node. Yes. Then let's change the function name. Only correct. Correct. Node dot left connect. Node dot right. Yeah. Let's submit it. Yes. Now it is working fine. Let's talk about time and space complexity. Pre-order will work for order of n. Post-order correct will also work for order of n. So the total time complexity is order of n. And this is about the time complexity. Space is the height of the tree in the recursive stack. So it is order of h. Thank you all for watching.